Welcome to my presentation called Rolling Out Database as a Service at Ghent University. This is essentially going to be a user story about how we updated our MySQL environment to a database as a service model for our internal customers. So I'll first start off with telling who I am. I'm Matthias. I have a bachelor degree in computer science. I started at the university in 2007. And most of the time I've been a PHP developer, PHP backend developer, with a keen interest in MySQL, and I was responsible for setting up our MySQL system, so I essentially became the MySQL DBA. I have one boy who turns 4 next month. You can see a picture of us on the beach. The university is the second largest university in Belgium. We've been founded in 1817, so we exist 200 years this year. We have 41,000 students and 9,000 staff, divided in 11 faculties and 8 administrative departments, of which our ICT department is one of the administrative departments. We have campuses in the Ghent area, Kortrijk and Ostende, which are both cities in Belgium, and we have one global campus in South Korea, which made a big difference in how we have maintenance for our systems, because we're no longer in one time zone. That makes a huge difference for us. So before we had a lot of nighttime, but now we don't. In our university is also divided throughout the entire city of Ghent, so we have campuses all over the place, so it's very hard for us to know everybody and know all the systems, but we try to. So that's how we came to database as a service. It's part of our effort to professionalize our ICT infrastructure. Before 2011, we had lots and lots of small data centers divided all over the campuses. We had servers in basements, we had shelves and closets. We had servers on the desks, under the desks, you name it, you could find them everywhere. So that was not very efficient. So in 2011, we opened our first real data center, where we opened it up immediately for co-location for our internal people, our researchers, our students in a lesser way, but they can if they want. We wanted to be more energy efficient, we wanted to be high available, and we also created a high performance computing team at that time where our researchers could have calculations on the clusters to be there. Then after we moved to that data center, we moved all our physical servers there, but that was still not very efficient, so we started virtualizing everything. So we added a VMware vSphere cloud, which is our internal cloud solution. We don't use AWS or anything else, we just use our internal cloud. That was more energy efficient because we didn't have a lot of idle servers anymore. That was more high available because we were not depending on certain hardware anymore, because we could scale that easily, and that was more fault tolerant. What we did not virtualize yet was our database setup. So we were still on old physical hardware for the database. And those machines are end of life, so we have to replace them. We had to replace them, so we started looking at a virtualization option for our environment. Because we are not really big, and the machines you buy these days are really, really big, and have a lot of cores and have a lot of memory, we started running multiple instances on those physical machines. That was also a problem, because we did not separate them in containers or virtual machines. We just ran them on the same kernel. So we could, in fact, not upgrade one instance by itself because they were all running the same binaries, and we even ran multi-tiers of the applications on that same system. So we had a dev, testing, QA, production cluster, all on the same hardware, so there was no way to upgrade. Our setup was, we had that setup on 2 different machines. That was master-master with active-passive situation. But there was no easy way to fail over to the other master other than logging into all the applications, change the config files, and yeah, that was painful. And our backup solution was also not very fault tolerant. We ran backups by creating sand snapshots, and that worked for us. But if you would increase disk size for a certain instance, and you would forget to do one of the steps in the process, then yeah, your backups would fail, and you would have no backups for that database, which was not very good. So we came up with database as a service solution. So we have a lot of small databases. We don't have one big application. We have a lot of small databases. We have a lot of research blogs. We have a lot of results. We do have a few larger applications, like 300-400 gigabytes of data, but that's not really huge. But we had a DBA, me, maintaining this setup. We installed it. I installed it. I designed it, and I set it up. We wanted to have a backup strategy that worked and that would keep working, and we wanted to have a failover and redundancy solution. So that brings us back to what we offer this as a managed service. So we run it in our data center, we manage it, we upgrade it, we test it. We wanted this to be high available. So if one machine would go down, we wanted not the database to go down. We wanted it to be durable, so we have backups. We can go back if someone makes a mistake. We wanted this to be maintainable. We wanted to be able to upgrade and test without having to bring everything down. And we wanted to be open for our internal customers. So that's why, as a service, we opened this up to our people. So, what components did we introduce? This is a list of components that we introduced, and I will go over them one by one. So we start off with MySQL. Why MySQL? Because essentially I came from a team that was using MySQL. We were doing a lot of things open source, so choosing MySQL was the solution for us. And we also wanted to limit the number of technologies we offer as a department to our customers. We already have an Oracle setup, Oracle database, and we do have a SQL Server setup for because we have a SharePoint thing going on. I don't know a lot about that, but adding one more open source solution for people to use was the goal here. So I had some knowledge about that. I gained a lot of knowledge by coming to these conferences, by talking to a lot of people, by reading a lot of blog posts, and by just trying out a lot of things that will probably went south a lot of times, but in the end, it worked out for us. And we use Percona Server 5.7. Why Percona Server? We came from Percona Server 5.5 on the old setup. That was good for us. And so we essentially chose to stay with Percona and to upgrade to 5.7 to have all the new features that were in there. So we run GTIDs, we run a lot of the new features there. Yeah. Next component was Proxy SQL. So we wanted our application to be separated from the database so we could upgrade our databases without having to notify all the users or all the different people that we were offering this service to. So we could protect the topology for being able to manage it and for we also use this as part of our high availability solution. So if the master goes down, there will be a new master that comes up, and that will be the new writer. We will do read-write splitting to use our slaves to serve the read traffic, and we do query mirroring for testing. So we use the query mirror features to replay our production load to a test server if we do changes, so we can be sure that our changes are for better and not for worse. Proxy SQL itself, we made high available by setting up 3 of them. And we put them behind a keep alive D solution where they are all active, and keep alive D sends traffic to all of them. And they are essentially managed by Puppet by keeping them having the same configuration. But I'll come back to that later as last part of the solution. For topology management, we use Orchestrator. There's some GitHub guys here. They essentially released that last year somewhere, end of last year, under the GitHub name. It was being developed before by Shlomi Nowak at Booking and at Outbrain. We have Orchestrator running automated recoveries. So if the master goes down, it will be Orchestrator calling the shots on who will be the next master and who will get the right traffic. And we also use this as a visualization tool for all our IT department. So any developer can actually see how the setup is constructed. They have a read-only view on that web interface. And we also, this is still in the process, I try to use this for monitoring purposes, because we want not just to alert on replication lag, on replication downtime. We want to know what server is the master, and essentially Orchestrator knows all that information, and it has an API to which you can query that. So I am now learning how Nagios works to be able to get that information out of Orchestrator and into Nagios to be alerting on that. If I ever come up with a good solution that is able to open source, I will most definitely do that. I will put those scripts online somewhere, probably on GitHub. Orchestrator itself, we also made high available, so there's no single point of failure there. So I was started reading the documentation on GitHub, and Shlomi put up a few hints on what to do. So I know the GitHub guys, they run it with a master-master active solution with AJ proxy in between. We chose to use PXC. So we created a 3-node PXC cluster with, on each node, also the local orchestrator. And they connect each to their local PXC node, and the PXC makes sure that all the data gets to all the nodes. So that we tested, and that works. And I tried to break it a lot of times and didn't get it to break. The only thing that is still a little problematic is our keep alive D config is not intelligent enough to know when, because we put in front of the orchestrator, we put in Apache reverse proxy to do authentication to SSL. And when orchestrator daemon goes down, then the Apache will return 503, servers unavailable, and our keep alive D cannot handle that yet. So we need to improve our checks. The only thing that then goes down is the web might go down is if keep alive D would send you to that specific server that is down, then you would get a 503 message in your browser. But on the other servers, there's a new active node elected by orchestrator, and it still keeps running the failovers, the recoveries, and you can still use the command line to view everything on one of the active nodes. But yeah, that's still a caveat in our setup that we have to fix. Next to that, we wanted to have backups. We use Extra Backup as our primary backup solution. That works out for us. We encrypt and compress those backups using Extra Backup, and we back them up to a network volume at the university. And that network volume then gets back up to tape by Bacula. We keep 7 days of backups on the network volume, and then Bacula keeps them for like 15 weeks on the tapes, so we can go back quite some time. We do full backups every day because the recovery time would be faster for us than to put incremental backups onto it. But we also keep our bin log files. We stream them to another location, so we can always do point-in-time recovery to a certain point where it might have failed. Yeah, essentially for backups. And we do test those backups by restoring them to a testing environment to have real-life data on a test environment so our developers can test against a realistic data set without, and that immediately helps us to verify that the backup solution is actually working. So everything said here is managed by Puppet. We were already using Puppet. We're a Puppet shop. We're currently in transition from Puppet 3 to Puppet 4, and we're doing that by actually rewriting the entire code base. So we create a new repository, a new Puppet master, and any new servers that we will roll out will be rolled out against that new version. We use Puppet to manage MySQL users and grants. So that means that we do not replicate the MySQL database because we want Puppet to be able to run everywhere automatically. So the single source of truth for any user credentials or user data is our Hira encrypted YAML files. So that's where all the configuration is. We also make sure that Puppet sets read-only equals true for any MySQL server that will start up. And it will also skip slave start on start to be sure that nothing nasty would happen with that topology. So we also use Puppet to configure proxy SQL. And there was no Puppet module available at the time that I was looking at it. So I wrote my own. I've been working with Renee for a bit to get that working. And I've open sourced that in the meantime on the Puppet Forge. It's available under the Puppet/proxy SQL name. Which leads me directly to this slide, being the Vox Populi slide. Vox Populi is essentially the Puppet community. Like there's a MySQL community where you can ask questions and they will try to help you. Vox Populi is a similar community. They do open source stuff, and they are taking care of orphaned or Puppet modules that only have one maintainer, like my proxy SQL module, where I'm essentially the only one who is writing to it. They have the namespace Puppet on the Puppet Forge. If you want to read more about them, you can go to their website. If you have Puppet modules that you want to donate to that organization, do contact them. They are very open for more contributors and more modules. And I'm going a lot too fast because I am at my final slide. I've probably forgotten a whole bunch of things, so if there are any questions. So the question was, how do developers get provision the databases? So essentially they would request a database first using a web form, and then we would create it for them. And most of the developers, for the smaller data sets, they will just use phpMyAdmin. The phpMyAdmin will connect to the proxy SQL and to the master, and they will be able to create their schemas and manage their schemas on their own. For the larger applications, that are mostly applications that are in-house developed and that we would support ourselves. Then we do schema management. I am looking at the schema tool that Evan Elias was presenting just earlier in Ballroom A. But currently, yeah, we run something called dbdeploy, which is actually a Java tool where you put your alter statements, and they have the ability to run those queries themselves. Anyone? No, we have a general purpose cluster for all those smaller databases. So we give them, essentially we give them a username and a password and a host name to connect to. And they will, in most cases, they will set up something like a WordPress, and the WordPress will take care of its own schemas, and that just goes through. I didn't have any complaints about that not working very well for them. So, yeah, Tom. We do monitor every machine using Graphite and Grafana dashboards, and we alert on certain metrics, like when there's queries long running. I do have ptkill running on every machine as a daemon, so if anything tends to take too long, it will be automatically killed. So we try to prevent things like that happening. But yeah, you cannot, for everything you cannot be sure, but maybe we just have very nice users that do not tempt us too much, so yes. We limit the number of connections in the proxy SQL, so you can limit by user. So I think by the default is that any user can have 100 simultaneous connections, and on request we could increase that number. So in the end, that's not really a big problem, and then proxy SQL also multiplexes the connections, so it will reuse an existing connection to the database. So that works well for us. That also said, we don't have a lot of users, so like at most 100,000 users. So that works for us. I imagine for a larger setup that won't work so well. But in our situation, we did split off some clusters that have a larger number of users to a separate system. But like the system that I was referring to, the general purpose, has like 50 gigabytes of data on it, so that's not really a big problem. We do have Nagios to monitor the disk space, and we alert pretty quickly when something out of the ordinary is happening. So if we monitor delta, so if sometimes there's a lot of increase of disk space, I would get a page and I would have a look for why is this happening, where is this coming from, and we would intervene if necessary. So, did you have a question? Okay. Yeah, then I think I have told everything I wanted to tell you. So, yeah. I haven't done that yet, but that would depend on where it needed to go. If it needed to go to its own cluster, we would probably start replicating the new master for that cluster from the old one and replicate with a replication filter only his data. And then we would do the cutover at some point where we were confident in the new setup. So yeah, that would be the case. Okay, thank you all for coming.